Okay, so we are going to review solving systems of equations. So here is one example of a system of equations. And when I'm looking at this, I am noticing that this is a good candidate for solving by substitution. It's also a good candidate, really, for solving by elimination. So really, this one can be solved either way. So I'm actually going to go ahead and demonstrate solving it in both methods. So let's go ahead and start with substitution. Now, both of these methods are really good. So when we are solving by substitution, we are looking for a variable that would be easy to isolate. And when I look at that, I definitely think that this y would be easy to isolate. So I'm going to do that by subtracting the 4x to the other side. And I get 1 minus 4x. And now what I'm going to do is, now that I know that y is equivalent to 1 minus 4x, I can go ahead and pull this equation, this top equation, down. And wherever I see a y, I can go ahead, so right here, I'm pulling it down, 3x minus 2y, and instead of that y, I'm going to replace it with that 1 minus 4x, because we said they are equal to each other. And so now I have an equation only in terms of one unknown. So I can distribute this negative 2, so I'm going to get minus 2 plus 8x. And I'm going to combine 3x and 8x and get 11x. I can add the 2 to the other side and then divide by 11. And I get x equals negative 1. Now, even though I got x equals negative 1, I'm not done. That only tells me an x value. But we also need to know a y value. So I'm going to go ahead and go back to either equation, whichever one looks easier, and I'm going to plug in x I'm going to substitute negative 1 for x. And so I have this equation, 4x plus y equals negative 1. That looks like the simplest equation for me. I'm going to replace x with negative 1, and now I have an equation just in terms of y. And so I get negative 4 plus y equals 1, and so y equals 5. Now remember that solving a system of equations is solving for a point of intersection. So my final solution is this negative 1, 5 ordered pair. This is the ordered pair where if we were to graph this equation and this equation, this is the ordered pair where they would intersect. So let's take a look at solving this same system of equations using elimination. So this is a good candidate for elimination because I see that this y and this y, this negative 2y and y, they're almost able to be the same term with opposite signs. All I need to do is be able to multiply this equation by 2. So if I multiply this equation by 2, I'm going to get 8x plus 2y equals 2. And then I can pull this equation over as well, which says 3x minus 2y equals negative 13. Now the reason that I want these terms to have the same coefficient with opposite signs is because now with elimination, we're going to add going straight down. 3x plus 8x is 11x. Negative 2y plus 2y is 0. And then negative 13 plus 2 is negative 11. So now I again am left with an equation in terms of just one unknown. I can divide both sides by 11, and I get x equals negative 1. Then I'm going to go back to my equations and pick which one's easier, just like we did last time. I still think 4x plus y equals 1 is easier. And just like last time, you're going to see it works the same way. We're going to replace x with negative 1. And we get negative 4 plus y equals 1. And so we find out that y equals 5. And so we again get that same ordered pair, because this was the same problem we did last time. That same ordered pair is the solution to our system of equations. It's the ordered pair where the equations would intersect on a graph, but we solved by elimination.